You remember a week like this. A heat wave arrives, and then it just stays. Day after day, the same white sky, the same forecast, the same heat. Or somewhere else it is rain, the same storm reloading over the same valley for days, until the rivers give up. Just this summer, in 2026, much of Europe sat under a heat wave like that for more than a week. And the strangest part was not the heat, it was that nothing moved. Weather is supposed to move. Storms are born, they drift, they die somewhere else, usually inside a few days. Your whole sense of weather rests on that motion. This too shall pass. So when a pattern parks itself over your home for a week or two, something has gone wrong with the moving itself. This video is about that something. High above your head there is a river of wind, circling the planet. Riding on that river there is a wave the size of continents. When the wave moves, your weather changes. When it stands still, your weather gets stuck. And whether it is about to stand still more often is one of the most open questions in climate science. By the end of this video, you will be able to look at a weather map and see the wave itself. Start with the river, because you have already felt it. Look at flight times. Tokyo to San Francisco, about 9 hours. The same route flown home, about 11. Somewhere over the Pacific there is a current of air so strong that airliners surf it going east and fight it coming back. Climb to about 10 kilometers, and there it is. A ribbon of wind a few hundred kilometers wide, running at highway speeds on a slow day, and 300 kilometers per hour on a fast one. Meteorologists call it a jet stream. Why should a river like that exist at all? 2 ingredients. First, the tropics are hot, and the poles are cold, and the warm air stands taller, so the atmosphere has a permanent slope from warm to cold. Air is always being pushed down that slope, toward the pole. Second, the planet is spinning, and on a spinning planet, nothing travels straight. In the northern hemisphere, everything that moves gets nudged to the right of where it was heading. Push the air poleward, add the spin, and the push turns sideways. The air ends up racing eastward along the boundary between warm and cold instead of flowing across it. That is the river. It circles the entire planet, and every storm you have ever lived through was steered by it. Now the strange part, the river refuses to run straight. Watch it from above and it meanders, bulging toward the pole here, plunging toward the equator there, like a lazy old river wandering across a plain. Those meanders are not random noise, they are a wave. And the physics behind the wave is spin. Every column of air on Earth is spinning, because the planet underneath it is spinning. But here is the key, the planet hands more of its spin to air near the pole, and less to air near the equator. And a column of air keeps its total spin, the way a skater keeps hers when she pulls in her arms. So slide the river toward the pole, where the planet's share of the spin is bigger, and the air's own share must shrink. The current starts turning back, bending toward the equator again. Slide it toward the equator, and the opposite happens. It bends back toward the pole. Displace this river anywhere, and it does not just settle down, it overshoots and swings back and overshoots again, all the way around the planet. The rule has a name. Conservation of spin, what physicists call vorticity. And the giant meanders have a name too. Rossby waves, after Carl Gustav Rossby, who showed in the 1930s that the wiggles are not weather at all. They are the geometry of a spinning planet, made visible. Around a full circle of latitude there is usually room for about 4 to 8 of them. Under each crest, warm air reaches far to the north. Inside each trough, cold air spills south. Whatever your forecast says this week, it is mostly answering one question. Which part of the wave is over you? Here is the property that makes everything else in this video happen. The wave and the river do not move at the same speed. The river of air always flows east, but the wave pattern riding on it always tries to swim west, back against the flow. Picture walking down an escalator that is moving up. Walk slowly, and the escalator wins. You still ride to the top, but match the escalator's speed exactly, step for step, and you hang in place, walking forever above the same spot. The small meanders swim slowly, so the river sweeps them east past your city in a day or two. That is normal weather. The biggest meanders, the continent-sized ones, swim west almost exactly as fast as the river carries them east. And when those two speeds cancel, the pattern stops moving across the map, a wave the size of a continent, holding still. Meteorologists call it blocking, because the stalled pattern physically blocks the parade of storms behind it, like a boulder dropped in a stream. On a weather map, the classic shape is a huge dome of high pressure wedged between two lows, drawn like the Greek letter omega, an omega block. Once it locks in, it can hold for a week, sometimes two. Now put your weather underneath that stalled wave. Under the stalled crest, the air is slowly sinking, and sinking air is dry air. Clouds evaporate, the sky stays cloudless, so the sun works on the same ground all day, every day. The heat compounds, because the one thing that would end it, a fresh mass of air, is exactly what the block keeps out. That is a heat dome. In June of 2021, a block parked over the Pacific Northwest, and the village of Lytton in Canada reached 49.6 degrees Celsius. A national record set under a wave that would not move, but the crest is only half of the wave. Beside every stalled ridge of sinking air hangs a stalled trough, where the air rises instead, and rising air rains. While one side of the wave bakes one country, the other side can reload storms over another, the same rain arriving along the same line, day after day, because the conveyor that should sweep the storms away has stopped. In 2010, one persistent pattern did both at once. A heat wave held over western Russia for weeks, while downstream the floods rose until roughly a fifth of Pakistan was underwater. Two disasters, thousands of kilometers apart, on the same map at the same time. Not two events, one wave. So the question you are already asking, is the wave getting stuck more often? Here is what is measured, and what is still open. The Arctic has warmed faster than the rest of the planet in recent decades. That part is measurement, not theory. And remember why the river exists at all. The temperature difference between the tropics and the pole. So the argument goes like this. Shrink that difference and you may weaken the river. A weaker, slower river should meander more, and bigger, slower meanders should find it easier to stand still. It is a serious physical hypothesis, and there are summers where the observations look exactly like it. But here is the honest state of the science. The reliable records are short, the natural swings are huge, and climate models disagree with each other about what blocking will do in a warmer world. The most recent IPCC assessment says it plainly. Confidence in overall trends in blocking is low. That is not a loophole, and it is not a verdict. It is what an open scientific question looks like while it is still open. The wave is real, the stalling is real. Whether the odds of stalling are shifting is the part the next decade of measurements gets to decide. Once you can see it, you cannot unsee it. A 5-day forecast is a guess about a wave. A stubborn ridge of high pressure on the evening news is a crest that swam upstream exactly as fast as the river flowed. And this shape, motion canceling into stillness, is everywhere once you look. A standing wave on a guitar string is a vibration that stopped traveling. A traffic jam is a wave of braking, rolling backward through cars that are all driving forward. The atmosphere is simply the largest instrument the trick is ever played on. So the next time the heat will not break, or the rain will not leave, look up, past the weather, and picture the planet from above. A river of wind circling a spinning world, 4 to 8 great arcs riding it, and one of them, for now, holding perfectly still over your head. The week that would not end was never about your city. It was the planet, briefly, holding its breath.